Hello and welcome to my FMOD Unity implementation demo. Here I have a map pre-made. It's an asset. All the graphics, of course, all the scripting, with the exception of like the camera or the thing that moves the player specifically, is all done by me. And I've got some interesting systems here for implementing some ambience. And some basic ones with some cleanliness for like basic type of SFX emitters, like from torches or whatever. I have created a enemy AI that also makes use of some of this audio stuff, of course, like based on the states of the enemy and stuff like that. And yeah, so let's just get right into it. First things first, we have our SFX emitters. So, for example, we have this torch here. We have one of these cogs over there. We have, the cauldron, and that was in that room, and some furnaces down in this room as well. So what's happening here? So open this prefab is I am putting a sphere collider of 20. It has like a radius of 20 units because that is the same as, I'm not sure exactly what the unit is, but in float, it's just 20. So in FMOD's engine, the maximum distance for the attenuation is 20. So at 20 float, we would no longer be able to hear the sound, and this is what the sphere sort of represents. So if the player is standing on the edge of the sphere, we are actually able to turn this emitter instance off when the player leaves, and then turn it on when the player enters. Additionally, here in the emitter script, I have I have an occlusion value. So if you actually come and take a look here at this emitter script, here I have that float, the occlusion range. We have our public event reference, a couple of little private things. Right away at the start of this object, we're going to go ahead and find the main camera. What it's like just find the object so I can reference it later, like what is its position, what is its status, etc. And then the way this event gets created and the sound starts coming isn't actually through start. It's based off of this trigger enter or exit. And we compare the tag of the collider to something that should trigger the sound, whether it's like the actual player model or the camera or whatever. So when we enter, we create the instance, and creating the instance consists of course, creating the instance and setting its 3D attributes and then starting it. And we also go ahead and we start this coroutine called get occlusion. And I just set this Boolean to be true in case we need to use this later. Now here in the coroutine, I am setting occlusion every single 0.1 float, so that's about 100 milliseconds. And then if the instance is created still, we just restart the coroutine, right? So this happens on the first, at 0, this happens at 100 milliseconds later, and then this would happen at that same 100 milliseconds or 101, right? So it's every 100 milliseconds. And then the set occlusion will draw a line between from where the object is to the listener that we referenced earlier, and then we will use the layer mask wall and ground, and we're going to ask if it's colliding or not, because if it's colliding with the wall, then that would imply that we're occluded, and then we'd want to use our max occlusion value. Otherwise, we're not occluded, and we can play the sound completely uninterrupted by any sort of occlusion. And if we leave, then we just destroy the instance, like so. We say bye-bye. We set this back to false. We stop the coroutine. It just handles itself. So then that way I don't have events existing outside of the audible range, because that would be a waste of resources. Yeah. So I did something a little bit interesting here with the ambience, because of course, when there's wind outside and I leave the windy area, I could just take the approach to fade from one ambience to the other, but that doesn't make sense, because then you question what happened to the wind. Theoretically, the wind should still be heard outside while you're inside of this room. And likewise, if there's any sort of humming or any sort of resonance coming from the wind in this room, you should be able to hear it when you're outside of the room as well. So I have all of these reverb zones here that they also double as reverb zones to set snapshots that every item in the game can use, every object or every instance can use. So I have all these boxes here. So if we take the medium hall as our example, we have something called an emitter, and then we have these two boxes here, so we can get a little bit more complex shapes, especially, for example, out here in this courtyard. we have this sort of shape here. And this one's really important to have this shape because we have this corner piece here. And we do not want this outside area to intersect with this corner. Otherwise, I would need to, for example, stop the wind here instead, which would be a little bit more sad. So I have these two boxes here, and these will act as a jail cell or little cage for this emitter. It can never leave its own box, whatever boxes or whatever parent. It can't leave these two boxes here. So it needs to stay within one of them. So the way I do this is I have a little bit of visual scripting here where I'm just grabbing the box colliders, sticking them into a list, and then grabbing the transform of the listener and again, making that as a reference. And then I have here this positioning logic, which should probably be called the selection logic actually. But this one is a little messy. This one will check up here and here how many things are in the list to make sure that, for example, if there's only one box, it doesn't run the second part of the list, right? Because that would just be a waste. So it checks how many boxes there are, and it's going to go through for every single box item, and it's going to check the closest point using that specific box as a reference. For example, this one uses the first box, this one uses the second box on the right side, and then it's going to check, well, what is it closest to? The player, of course, what's a point within that volume that it could get to the player the closest, what's the best one. And then we set some values for that. And then we have this selection logic, which will go ahead and actually set the position of the emitter based off of which one is closer. So it checks that here, which one's the nearest collider. It will find the nearest collider, and then based off true or false, we'll select the flow, and then we input the closest point from one of those two boxes, and then change the position of the emitter, and that's how we get the emitter to follow the player all the time, and also stay within one of these two boxes. Unfortunately, closest point doesn't work on a game object that has multiple box colliders, because it will just pick one of the box colliders, the first one that gets put into the internal list of box colliders that game object has. It will pick the first one. So I have to do something to kind of select between the two of them. And that's how I opted to do it. The boxes themselves are literally just box colliders that use the very basic FMOD Studio event emitter that on trigger, enter, exit, and the collision tag is the player. It will change the reverbs or the reverb that's happening on the master channel. The emitter itself is practically identical to the other emitters being used, with the exception that the occlusion is a little bit higher to make sure that the wind outside isn't too loud when you're standing here. We wouldn't want it to be too loud through the walls, right? But it's fine here, and for the most part, it shouldn't be occluded too much. And the way I have occlusion set up in this in general is kind of its own thing, where, for example, these are called decor, all these and these railings, these pillars. And then these are actually walls, and then this is the actual ground. So only the walls and the ground can occlude things, and if I so wanted to, I could also make it so decor could occlude things just significantly less. For example, decor could occlude only by 0.3, where a wall could occlude by like 0.6, right? And maybe the floor actually occludes by like 1, so it's completely blocked. So we can hear the ambience in action here. If I stand maybe in this room, we have a small room ambience. When I come here, we can hear a little bit of a sound coming from the right along with the torches. It's very subtle, but you can hear the other ambience, because right now it would be positioned inside of the doorway, staring at the camera. And right now, this room's ambience emitter is literally inside of the camera, which makes it feel like a 2D ambience at this point. As I come over here, we hear some wind on the right side. We walk out. yeah, so that's how the ambience works. I think it sounds quite nice. So for the next thing, let's take a little peek at these little jars here. I have this script here, the shard script, which will just go ahead and do the utmost basic creation of events ever. But it will also, before it even plays or creates an event, just double check that the velocity is sufficient on the get component rigid body velocity.magnitude. It'll just check that it's fast enough, because otherwise you'll get like a really overloaded engine and like lag spikes. Even though it sounds kind of cool to have all those events, it doesn't really work. And then we set the parameter of the this rigid body's velocity to the parameter of the shard velocity, and that will control the volume and the pitch of the sound. So if it's at 1.5, it'll be pretty quiet. I think it can go up to like about 3, 4, 5. So it gets much louder if it's very, very fast. Give it a little bit of dynamic life. The actual thing that spawns that's broken is this thing. Has all these shards here. So when I import this from Blender with the FBX, I could just grab all the shard pieces, and I would add the rigid body, the mesh collider, the shard script. I could set the mesh collider's parameters and the rigid body, of course, all together, set the material. And then in here, I can also select the audio event, and that will change it for all of them. One really cool thing that could be done if I had a little bit more control over the fracturing of the object in the first place would be that, for example, here on this box or this barrel, there's obviously some metal on there. So it would be really cool to put together the mesh collider of this barrel in the first place, right? Here in this barrel. It would be very interesting if this metal piece was actually a separate, or had a separate mesh collider for it, which I could use for collision events, which would make a more of a metal sound, while the wood would make, a wood sound. And then when these pieces would break, the metal and the wood would fracture independently, so that they could remain to have their own material sounds, even in the fractured state. Because this would be the only object that would have that sort of wood sound, right? Would just be this wooden crate, but of course there's some components that have multiple materials. In the case of the jar, though, it's all just ceramics, so it would just be, that ceramic type sound. On start, I just grab the capsule collider specifically. I don't care about the mesh collider at all in this context. I am then checking that on trigger enter, is it the sword? And if that's true, then we go ahead and we set the collider down here. And then we get this custom event called take damage. Now this actually comes from the sword. When the sword collides with something, it will attempt to send a custom event called take damage to the object it collided with. The sword is only allowed to collide with certain things right now that have certain tags, such as destructible or enemy. So it won't try to just spam send take damage to like walls or anything, because they can't take damage in the first place. So then we go through, we just double check that this variable is null or not, and then we grab its position and we ask on the capsule collider what's the closest point to the sword's position, and then we will get the rotation of the capsule collider, and then we spawn this little this little VFX here. We spawn that. It's just like a little, it's like a sword, little blue like sparks or something, right? And we just spawn that at the closest point, so that way it stays relatively attached to the surface of the jar, so it looks like our sword's actually hitting it. And then here for the audio, for the fractured piece, I just snapshot the vase's position and rotation, and I apply it to a spawned fracture object, which would be the fractured jar that's been pre-fractured from this exact model. And has been kept together. So when it spawns, it will look the exact same for like a millisecond, and then fracture, right? And then I destroy the original object, of course, because I'm not actually fracturing the original object as I'm just not. I'm just using the other method instead. And that's just how the jar works. It's just that simple. The barrel works the exact same way. Here in the Blender setup, we have something similar. All right, so the next thing would be the player. The player, we see them all the time. It's the main component of any game, I would say. So here, our player knight. I have 3 custom scripts on him, and a script machine that I've set up And then there was a third-person controller that already had the WASD and like camera logic sort of set up ahead of time, which was very convenient. I did make some amendments to it to add functionality for not being able to sprint if I don't have stamina and things like that. But one of the first things I did on this player, which I later changed to be visual scripting because it was easier to sort of set up a different system for detecting the material the player was standing on, was I used something like this, and this is probably what everyone or most people would do, where we're just we're doing this sort of current terrain thing with a private enumerator, right? So we do this thing, we get a raycast hit, we pull back an array, we're checking all the things that we're hitting, right? We're trying to check each single thing and then set current terrain to be .stone, .this, .that. And then down here we have a switch and we're saying, okay, we'll play this footstep, play this footstep, play this footstep, because then we input an integer into the actual function itself. And then down here we would say like the terrain is terrain, right? And the terrain is this integer that we get from the switch and so forth and so on. Are we sprinting? You know, what kind of movement type do we have? Things like that, pretty much. So yeah, I didn't stay with this because I highly dislike using layers, period. I think like layers are very limited. I think layer should be the absolute last thing ever to be used for anything like this. I get that it's an audio demo, but in my opinion, that doesn't matter. Do it like I think you should do it the best way possible, and I think the best way possible is to not have you know, 10 of your 32 layers, not even less, because some of them are obviously taken for other things, be sacrificed for audio. That doesn't make any sense. So yeah, I ended up just saying, okay, whatever. I did something else on the player footstep. So that actually got replaced with a script called FMOD player. So this one's set up to work a little bit better with visual scripting. So here I have some, you know, some private event instances for the footstep, jump, armor, hit, and same thing for the references, so I can set those. And then in here I have play jump, right? And then this has, this creates an instance, does the thing, right? Starts it, releases it. And then here I have play footstep, and these have integer inputs, right? So I can set some parameters when they're called. And that's pretty much how this works. It's just 4 functions that are unconnected to anything, and they have inputs, and I could also give them outputs as well in some scenarios too, if I so needed to. But then how the way that works is if I were to come in here and we were to go check out how, for example, the footsteps are being called, this is the logic for the footsteps. So whenever we get our animation event of the player stepping on the ground, we're gonna take the integer out for that to get the movement type, because the event is called, the string is called footstep both ways, right? So on my player night here in the animations, I have my walk like so. So in here I have string footstep 0 integer, but then in the run we now have a integer of 1 because our movement type has changed for that scenario. So then we can come in here, we grab the integer to input the material, or sorry, the movement type, and things like that. And this is sequence, so it should run this top line first. And what does the top line do? It's gonna do a raycast. I spawn it at 1 and launch it down 1 because I couldn't get a number small enough that would stop the raycast from penetrating multiple layers and giving an incorrect like response in the expose section, right? So I'm essentially casting like with the same thing the other one the script was doing. I'm casting a ray down. I'm using some layer masks here, so I still have the dirt, stone, rug, etc. all set up, but actually everything from wood of like night could get removed as well. Gravel, like enemy, etc. Those could all get removed. But like there's quite a few layers in here that actually just get deleted completely. And what that will, but anyways, it will check all those layers, specifically the ground and the wall, for walking on now, right? Because I use a different system. And then I'm going to get the collider, and I'm going to get its material. I think this is like infinitely such a better way to do this, because like if you're working with games that have physics or anything, you're going to always have a physical material on any type of mesh collider or box collider that an object uses to keep the player from falling through it or walking through it, right? And why not just grab that material in the first place and then make the basis of the sounds off that, because that doesn't take any layer channels and it's very, very easy. So, and then in here, I'm just checking for all of these things here, right? Like stone, wood, dirt, etc. Like all these different physical materials that I have set up. And in some scenarios, we might get vase or barrel. If I were to actually move this, you can see that barrel, both wood and barrel, are getting integer 1, right? So that's how that's all set up. And that will set the material. And then when the sequence hits 1, it's going to go and try to play this footstep. It's going to grab that material that we just set based off where we're standing right now. And then it's also going to throw in the movement type of the player. Is it 0 or is it 1? Right? To change our switch, to change some of the parameters of what's happening. And that's how the footsteps work. So by doing this, can completely avoid using layers. Because I think, obviously, a game would have, maybe not ground or wall or ceiling, but it would have a layer for the environment that is around your player, and you could effectively just probe that layer for any type of materials, and then use those materials to change the materials that you're walking on, rather than just giving 20 different layers for the ground. Imagine that would be pretty awful, I think. Yeah, so that's the player's footstep. What else do we have going on with the player? Well, we have the stamina thing going on with the player. So when the player is running around, we saw the stamina bar gets low, he'll start huffing and puffing. So the way that works is I have a script called player stamina. And this was, again, one of the first things I set up after I got the footsteps going. A public bool for sprinting. I have the public float for how much stamina it has. And then I have this boolean for like if the player is actually like moving, and then like what's their actual speed, right? And then of course the actual event reference for the player it's himself or whatever. Don't need to say fmod.studio because we're already using the namespace. And then the event instance. So on start, we're gonna play the instance. We're gonna create the instance, because it's one of those things that's just gonna be always attached to the player, always ready to be run. And here in the actual play instance, again, we run all of those things. We set the event, we attach it, we set its 3D attributes, we start it, it's done, forgotten about. The player exists all the time when you're playing the game, so there's no reason to ever turn this off or release it for the way it's configured, which is that the louder, the lower the stamina gets, the more often a breath will play, and the louder the breath will become. Right, so we don't need to turn that off or on. So then we also do our coroutine, and we do the coroutine stamina logic, which is down here. So this is doing like for each, like it's doing like a for each. We are going to say if we're not sprinting, then our stamina can start regenerating. So it's going to double check here. If our stamina is less than 100, we can add 4 to stamina, right? And if our stamina is greater than 100, then we're just going to set it to 100, because otherwise we're going to end up with like 300 stamina or something, right? It's going to be broken. So, and then if we are sprinting, we just check if our stamina is greater than 0, we're just going to go ahead and we're going to subtract 2. And if it's actually less than 0, we're going to tell it to equal 0. I'm using 4 and 2, so it's actually literally impossible for the stamina to ever reach below 0. If this was 3 instead of 2, then it could be possible that we hit like -1 or -3. Not -3, -1 or 2 or something like that, right? But with 2 and 4, it's not possible. But anyways, it's just to make sure that our stamina doesn't, we don't go into debt with our stamina or something. And then when that's done, it's going to yield a return new and sort of restart the enumerator again, which is nice. So then here I have this void subtract stamina. So this is actually for when the player swings. It's just a little function that the sword or the player itself can call in this, which will just slash 25 stamina off the stamina, total stamina if I swing. Right now, this doesn't actually stop you from swinging, which is kind of funny, but it's there anyways to make your guys start breathing heavily, I guess. And then also make it so you can't, like, swing a whole bunch and just run away. But yeah, and then we have this void update parameter, and this is happening. When is this happening? Over here in the void update. Oh, look at that. So we're updating the parameter. We're checking for sprinting. We're checking if we're moving all the time in our void update. So then our moving check is quite simple. We're just checking, like, does our character controller have a velocity on Z or X, right? Because if it's not 0, then we're obviously moving. We don't want to be able to drain our stamina while I'm standing still and holding shift, so we need to do this sort of checking to see if we're moving or not. And then here in the sprinting check, we're just checking to see that we have a certain level of stamina, or our stamina is this, or we're not moving, or we are moving, etc. We're just checking these various little variables, these little checks, just to make sure that we can only sprint when we can actually sprint, and then we get kicked out of that right away. And that's how the stamina works. And by essentially just running the stamina to the FMOD, to this FMOD event, it will just pretty much control the volume of it, because it's running all the time, it's always looping, and the lower our stamina gets, the faster the breathing will come and the louder it will become through the stamina. So I guess real quickly, some things that I've done here are mostly, I do a lot of animation events because they just work so well, in my opinion. They just work so good for relaying information accurately to what you're seeing in the game, which is really nice, I think. So here for the player, we have, of course, our events for the footsteps, right? We already talked about this. And then we also have our jump sound. So here we actually get a jump. This one's called play jump. It's not set up through visual scripting. So our player can actually jump here and we can get that sound. We can get that event through into making a instance in FMOD. And then we have the player land. So here I actually have 2 footsteps get played. So I got 1, 2, and then they kind of get played roughly when the feet are hitting the ground. And then we also have, I think, a run and land, which is kind of more like this, right? We have our 1 foot slam down, and then we just run. And then these ones will play that sprinting footstep, so it's a little bit louder, a little bit higher pitched, right? I have, for example, a unequip animation here, and now this is where a couple more interesting things happen. So this is a completely custom animation, if you couldn't tell by how cursed it is. Professional animator for sure here. No, come on, it doesn't look that bad, right? I mean, I got the hand to line up with the sword really well on the pickup and grab. It's quite smooth, but the right arm needs a little bit of help here. It's real hard to reach for that shield, you know, and all this armor. It's quite difficult. But so here I have all these integers. I didn't think about using integers and checking for values instead of just making all these strings before at this point. So there's going to be a couple here that are named weird. So I have 2 unequipped ones, and then I have unequipped sheath, which actually runs the logic for destroying the fake sword and shield on our back and then putting the real ones in our hands, right? And then vice versa. That's what the unequipped sheath is used for. And then it's also used for the main sound of the equip and unequip. So here in the trigger animation event for this first and last one, these ones actually run just some armor Foley, pretty much. So, and I do the exact same thing with player attacking. So here we have that uppercut. We don't have a sword right now, but for example, there's a start component to this, so this one might be missing some stuff. Like we have the uppercut start, right? So we start moving, so we get some armor Foley immediately, and then we get some armor Foley when we reach sort of this little section here, which is our combo transition over here, and that's why it's missing the event from here. And then we have our actual swing, which plays 2 more Foley sounds, and then we have a little sound here for when he starts to lower his arm, and then a sound to sort of finish it off, but not quite when he reaches neutral. It was a little bit weird, so a little bit before. Another little Foley sound for the armor, and that happens on all the swings, on the unequips, and the footsteps themselves have an armor layer in them, a bit of a Foley armor layer inside of them in the first place, just to give again that knightly sort of sound to our dude here. Here's some reference for what that sounds like. Yeah, so he sounds like a unit. Sounds like he's ready to go. He's all armored up. There's no mistaking that he's wearing some armor. And, you know, setting that to the event was quite easy. I just used this little armor graph, and I just grabbed like these little slashes and this unequip. So every time unequip or uppercut or slash is played, it just plugs its integer into a integer called armor status inside of play armor, which is inside of this player script, this FMOD player. We have this play armor. We input the armor status, bang, you know, we just run it, no problem. And that's really it. And that's just how that works for the armor Foley on the character. So the player's weapon itself actually uses a bit of, it's again, very simple, like C# stuff, because I mean, it's like, I'm just triggering a sound, like there's nothing insane happening, right? For this right now. So I'm just sort of doing this play, and we're just going to get the weapon status. Now, the reason there's a weapon status, actually, is because the weapon will get played multiple times. For example, in this little part of the graph here, so I actually have the equip set up here, right? So if I press X on the keyboard, we just do the, it's called unequip, but it's like, it's both, right? I just reuse it. So this is a little bit funny. I pretty much just, during the equip, I just grab the objects, the references to them, and I just check if they're enabled or not. And then based off of like it being enabled or disabled, it will set it enabled or disabled. And then what it will do is then also grab the status of the, it will also set the unequipped version of the shield, because there's two of them. So here we have sword unequipped and shield unequipped. So they just exist as they do. I think it might be the sword itself. I think the sword and the shield have a script that turn off all of their components if their mesh collider or their mesh renderer has been deactivated. So I would pretty much just deactivate that based off of when I press this button and I do the unequip. It's just checking if it's enabled or not, and then based off that we'll run everything, and then it plays weapon status, right? So it'll actually play weapon status 0 and 1, because the weapon status there on 0 is like the unequip, I think. If I were to come into FMOD and click on player sword, we have unequip, and then we have our equip, and then we have the hit sound and the swing. So these are working to effectively be all in one little instance that can just be created and messed with all the time, instead of just having like 20 different instances for the player. We just can have the player sword, and that can handle like all these different things. So we send the integers through to get different results using that, and that's how unequipping the sword works. When we swing, so we do some checks for like firing. Do we have the sword equipped? Can we attack? You know, what's our next attack? Because I have a comboing system in the game where it alternates between that uppercut and that slash. And if you actually press within a certain time frame, you can skip the startup animation and the rest animation, so you can do the attacks faster, right? So that's what all of this is going on. That's what all of this is going on here. The blocking I don't really have implemented right now. It's just very like, it doesn't do anything. It's just a visual. Here's for like subtracting the stamina. Over here is the logic for sending the damage. We're just grabbing the collider. We're double checking, is it an enemy or destructible? And then, yes, we're allowed to send a message to that object called take damage. And then we trigger that. This is for the script, the actual script component. If there's a C# script, this one's for if there's a visual script on it, it can also grab it that way as well. And then there's a cooldown, so it doesn't get too spammed. And then also so that we can do our like a little weapon sound here. So this plays weapon status 2, which is our hit sound. When we actually swing, we're playing a different sound in here. So over here is like where we check slash, we check uppercut. We're checking for integer values all over the place here. And we're then setting all these variables, and we're setting like booleans inside of the animator itself for transitions, so we can transition between our different combo setups. So like here in our animator, we have our swinging, which is set up on a layer that has a layer mask to prevent the legs from getting messed with while we're attacking. So I put this on a separate layer below. So we have the uppercut, which is the starting of the attack. So this would actually, we would play the uppercut, it would transition to uppercut combo, and then during the uppercut combo, we can transition between the two of these freely based off of what our next attack's going to be. So this gives us like a really smooth, if you can see down here, this gives us like a really smooth sort of back and forth type thing that we can start doing, which is really nice. We have our take damage in here and stuff like that, you know, like our block, our recoil. We have our equip here, which is just done doing like a couple arms and things like that on a different layer. That's for doing the attacking. And then of course, when we do an attack, we would play the swing sound. We also throw in the particle system to get that blue streak in the air when we swing our sword. There's two different particle systems that are inside the player, but just they don't play on awake, and they need to be triggered. So then we just pick one of the two to play when we swing to give the sword some nice juice with our attacks. So the player has a bit of a system in here for on the player's trigger enter. It checks for right now just our one weapon that we have called the Gemar. It's just like a gem hammer. We check if that has hit us. And then if it has hit us, then we try to grab its parent, and then we try to grab its parent's animator, and then we check that the animator is playing an attack. It's playing like an attack animation, because we don't want to just walk into the hammer while the giant or the rock golem is standing there, walk into the hammer and then just take damage for no reason. So yep, and then we run this take damage argument, and then we attach some damage values to it. And then here I'm just playing the hit this way. This hit sound includes pretty much everything in the player. Like it includes like the contact sound of the hammer and everything, just for the sake of throwing it down. So it's this one. That's the sound of the player being hit. We got the grunt, some various layers for things, right? Like armor and bones and whatever. Sounds a little Tommy, a little bit like a tom drum, but yeah. So I'm just playing that all right now on this player, but again, like obviously we'd probably want to have the hammer make it sound a certain way, and like, you know, kind of organize that a little bit better, so that way the hammer could retain some of those melee properties when it hits something else than just the player as well, or else just duplicate that. And then we have the take damage argument, which just says take damage, it plays an animation. Then we have our actual health over here, and then here in the health, when we take our damage, we be like, okay, we're taking damage, and then we would subtract the argument that comes through with it by the player health, and then we would set the player health, and we ask if the player health is like less than or equal to 0, then we just go ahead and practically just kill the player, effectively play a little death animation, and then just kill the player just for fun. Yeah, and I mean that's like the entire player. That's just the entirety, I think, of how the player works. One additional thing is that the sword in the hand of the player actually has its own script as well here. So I think this one's quite simple. This one is just saying, is our mesh renderer visible? Because we want to just set the collider components of that sword based off of this mesh collider or this mesh renderer's status, to make sure that our sword on our back is unable completely to interact with anything in the environment effectively. That's just completely how the player works. It's just like that. So I suppose the final thing would be moving on to this golem. Yes. So yeah, this golem, I just plopped down the model for this rock golem. I gave him a skeleton. I modified a couple animations to make him walk, slowed down a couple of them so he'd be a little bit more slow and weird looking. Gave him a hammer, adjusted the arms in those animations so his hammer doesn't like clip in the ground all the time. Yeah, a few things like that. He has a few custom animations as well, completely custom. And I mean, you'll be able to tell because they're absolutely kind of terrible. So we have this stomp. This is one that I did. So in the stomp, the golem will go and do something like that, and then do a little bit of a stomp. So this is sort of like a ranged attack the golem could have for initiating a player, because he has a couple states. I don't have the stomp. I have the stomp as implemented only visually. There's no actual logic behind it. That's going to be a little endeavor of its own, I believe, to get something that works really, really well. But there is a setup in progress for that one. And then there's the golem attack, which is I had to modify quite a bit because the animations in this pack were very, very bad for the one-handed swing. So that's why I made the animations for the player's swing, the combo system, all completely from scratch, because the attack animations of this pack are something else. So this one, for example, like the hammer didn't swing far enough, so I had to set that up, and then we have some trigger events for attacking and like some values that come through with that. So he has this classic little swing here, and that's just how we set up. The golem itself runs a system like this. So there is this is just for like testing him when he like dies and explodes, pretty much. This was for testing, forcing him to stomp, and then yeah. So I guess we'll just get into like his logic. He does use footsteps, but they're pretty much this simple. We just set the loudness of the footstep based on his speed, specifically for the golem, and then he's just plays like the same footstep type deal. He has a setup for getting damaged if he gets hit or whatever, right? Detecting if he's taking damage from the sword once again. He has his little stomp system. This is literally as deep as it is right now. He just plays a particle system so that some stones will come out of the ground. This is for the VFX of getting like hit, to spawn that little blue like friction or like metal grind or whatever type VFX on him. It just sort of spawns that in place. That's all that really does. And then, yeah, so a lot of the actual stuff happens here in the state machine. This is, again, one of the reasons I used visual scripting was for the state machine. So what the Golem is always doing by default is it's free roaming. I could actually maybe start playing the scene. He kind of walks around and we can see that he has these states down here. On start, by default, he will enter this check for player state. And in here, he's doing a check sphere to check if the player is within a determined area. In this case, it's like 12. It says it's 12 here. And then it's checking for a layer mask, which is set here, which is for night. It's checking if that's colliding with his sphere or not. And then here we have check for stomp range, check for melee range. So again, these are just additional spheres doing the exact same thing. They're just smaller. There's like a variety of circle, or not, there's no sphere colliders, but there's 3 different check spheres happening at different layers. And then we can say, yeah, you can melee, yeah, you can stomp, or like, no, you can't, no, you can't do that, you can't do this. You have player LOS or you don't. So it's checking that all the time. And then we have something here just kind of running the animations, basically. And then he free roams by default all the time. And free roaming looks something like this, where if I press tab, I can force him to find a new position right now. But when the state is entered, or when he finds a destination, we trigger an event. So that way we can co-routine it. And then this will allow me to get a random range, and then I will divide that range to get like much smaller, and then we have a random wait for seconds before we actually tell him to go to his new destination, because he's reached his destination, so he doesn't just immediately go from spot to spot to spot. You'll see that when he actually hits his destination, he will stop right now, and then he'll, you know, kind of walk around, do something, etc. So then we plug in the free roam range here to create a vector. We take that vector, we multiply it by a location inside of a random circle, and then we remap that circle to, instead of be XY, to be XZ, and he is then walking based off that. So when he has reached the destination within a certain success level, he will play a status sound, which is his like roaming sound. And again, we have a status here because the enemy status has like 5 different switches with all different sounds, from being hit, patrolling, finding the player, dying, etc. It's all inside of one switch, or one event just being switched. And then when we leave the state, we will play the found the player sound. We play that on the leaving of the state with a small bit of a cooldown to make sure it doesn't get spammed. So if player LOS, we just do this on a fixed update. We just check if we have player LOS, and if we do, we can trigger the transition, so we're allowed to leave free roam and come into player LOS. Player LOS, on a fixed update, it's going to grab our player night. This is a bad way to do this. I should be grabbing the player night on start and then referencing its position, but oh well. And then it's going to move to the location of the player at all times, constantly, when it's in the player LOS. And if we ever reach a position up here in our check for player, where we're allowed to stomp or melee, we will then transition out of player LOS to example for the stomp. And in the stomp, we're going to reset our path. We're going to say that we're attacking. We're going to find the player knight. We're going to look at him. We're going to wait for a second. We're going to play the stomp animation. We're going to wait for the amount of time that the stomp animation takes. And then we're going to set the nav mesh to be unstopped. We're going to set attacking to be false, and then we're going to say attack completed, right? And then if the attack's completed here, attack completed, we're allowed to leave and return back to player LOS, which will then check for the player, like go to the player, right? Because maybe we got a little bit closer. And in the context of the stomp, we actually have a cooldown so that the golem will stomp and then go follow the player and move closer to the player, so he doesn't just spam the stomp and rely on the player to get close to him. He will get close to the player, but he'll throw out some occasional ranged attacks, essentially. So for the melee, when we're in the melee range, instead of going to the stomp, we'll come to melee, which does the same thing. We say we're attacking, find the player, look at the player, you know, attack the player, play this weapon status for the enemy, do a bit of a cooldown, about 2 seconds or so when the attack is completely over, and a little bit after. Could maybe make this like, you know, 1.5 might be a little bit better instead of 2. And then we trigger all this, and on the animation event attack, when we get back the float value of each attack value, and we can play those in the event instance that we've created. So then if the golem were to get hit, it would say that it got hit because it played an animation, right? So that's an animation event for being hit, and I believe that resides here in the golem. There's a section here for damaged, so if he takes damage, he does all this, and he'll also say to play the animation hurt, when he takes damage. So then in the state graph, when he is hurt, he'll come into this hit state, which is just, it's just nothing. This just resets and says he's not attacking anymore, because otherwise he would not be able to attack anymore. If he were to start an attack and then I were to hit him and interrupt that attack, he would then transition into this state and be unable to attack for the rest of the game. And then on the hit cooldown, he's allowed to transition out of the hit state back to the LOS, which is like our neutral state. If the Golem's able to be hit right now in this context, he's going to be in player LOS. If, for example, we had a ranged weapon, we would want to transition out of the hit state to a different state that would try to go to the player, or an event that would launch an attack back, or like whatever, right, based on the scenario. Yeah, that's how that works. And then when this just checks, is his health 0 or not, and then this will just put him in the death state. So if I hit him and he dies, he's unable to like kind of slide. He has to stop moving pretty much. And then we spawn the dead rock golem. We get his transform information. We set that to the object that's going to be, right, we're actually grabbing the Gemar, the hammer, because we're spawning the hammer as well, separately. So we actually spawn the hammer separately, and we play an event for the enemy dying, and then we destroy him. So we're spawning the weapon, we're spawning his body, and his body is effectively, yeah, so I stick this in here. It just kind of falls apart, right? He'll just, he'll calm me, he'll give me a hit. I can hit him back, I can interrupt him. The hammer's a little bit wonky, maybe it shouldn't collide with the player in the classic sense. It gives us a nice satisfying pop when he dies. Yeah, that's like the entirety of this project.